Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of lines. Looking at the problem statement, the top view of the line AB, 80 mm long, measures 65 mm and length of its front view is 50 mm. The end A is on HP and 15 mm in front of VP. Draw the projections and measure the true and the apparent inclinations of the line. So looking at the problem statement, we can arrive at a set of conclusions. That is, the true length of the line is given, which is 80 mm long. And also, this line measures 65 mm in its top view, that is in the horizontal plane, and the same line appears to be 50 mm in its front view, that is in the vertical plane. Also, the location of the end point A in the space is given to us, that is, it is 15 mm in front of VP and it is on HP. So we need to draw the projections and also measure the true and the apparent inclinations. So now, using the data that is given to us, let us do the drafting. We'll begin with drawing the XY line. So draw the XY line of any arbitrary length and annotate this line as XY, the principal planes, that is VP and HP. Select the line option and we will mark the projection of the endpoint A, which is 15 mm in front of VP. So with this point, we can also draw the locus of this point A, and the locus of the point A dash will be on the XY line itself. So considering this as the top view of the point A, this will be A, and this is the front view of the point A. Because it is on HP, it will be appearing on the VP, that is on the XY line. So this is the point A dash. The locus of this A dash will be on the XY line, and this line is the locus of point A in the HP. So now we have to be very careful with the data that is given to us. The true length is 80 mm and the top view of the line measures 65 mm. So we do know that the top view of this particular line, which is going to be here, will be parallel when it is intersecting with the locus of A. So using that knowledge, what I'll do is I'll select the line option of 0.13 mm thickness, and here I'll mark a line of 65 mm. So why 65 mm? Because this is the apparent length of the line in its top view, and this is the apparent length when it is parallel to the XY line. So before we draw the true length, we can mark the 65 mm line. So this point will be B1. So AB1 will be the top view of the line AB1. That is when it is inclined at its true inclination. So now using this data, I can just draw a line perpendicular to the reference line. So I can just analyze that this will be the line which is going to intersect the locus of the point B. So how can I locate the point B now? So from line option, considering A dash B dash, I'll be drawing a line of length 80 mm, that is the true length of the line. So this 80 mm, which is the true length of the line, has to intersect this particular projector line that is being drawn from B1. So this point will be B1. So I can just draw the locus line of the point B passing through this point. So I'll be using the trim option and trimming this part and annotate this point as B1 dash. So A dash B1 dash is the true length of the line, that is 80 mm, when it is inclined at a particular angle to the XY line, and that A B1 will be the top view of this true length, that is A dash B1 dash. Okay, so now we can just measure the value of alpha here. So this is 36 degrees is the value of alpha. Okay, so now we need to mark the front view length of the line. So for that, we'll select the line option again, and in the front view it is measuring 50 mm. So let me change it to a continuous line of thickness 0.50 mm. So from here I'll be drawing a line of 50 mm length and ensure it is going to intersect this particular locus line of B. So this is the point where it is intersecting. So let me just annotate this line as locus of the point P in the vertical plane. And this point is A dash B dash, which is the front view of the line AB. So the alpha value is 36 degrees, and I can measure the value of alpha. So the value of theta is 36, and the value of alpha is 69. So the value of alpha here is 69 degrees. So now we do know that the projector of B dash, if drawn perpendicular, will be also having the point B, that is the top view of the point. So using that concept, let me draw the projector line of thickness 0.13. So it is a 90-degree line. So I do know that if I have to draw a line of 65 length, that line will be having its endpoint B on this projector line. So this is the procedure to draw the projections of line when its apparent length is given and the true length is given without the data of any true inclination and the apparent inclinations. So now we know on this line the point B is also going to lie. But however, to mark the location of the locus of B in the horizontal plane, so we shall see what can be done. So what I'll do is I'll select the line option. I'll select the continuous line of thickness 0.50, and from the endpoint A, I'm going to mark the top view of the length, the top view of the line, which is 65 long. We're going to intersect the projector here. So I understand that the projection of P is going to lie on this line, and the locus is also going to pass through this point. So for that, let me select the locus line, that is a dotted line, and try to draw the locus of B in the horizontal plane. So I'll label this as locus of B in the HP. So now this data is known to me. Now I need to draw the true length of the line in the HP. So for that, what is the procedure? So first let me measure this inclination. So the value of beta is 74. The value of beta is 74. So now I need to measure the true inclination of the line in the HP, that is with respect to VP. So for that, I need to draw the true length of the line. So for that, what is the procedure? So let me see. I'll select the line option and I'll complete this step first. So let me select the tangent arc, arc by center. So AB1, it is going to intersect here. So this point of intersection is correct. I'll change the arc to be a continuous type. Okay. So now this part is over. So now I'll do the reverse for this. So what I'll be doing is I'll be rotating this line and getting it here and then drawing the true length. So for that, select the line option. So be selecting the arc by center point, ensure it is a continuous line, measure this and cut an arc. Because the locus of the line A dash is also on the XY line, I'm going to stop it here. And from here, I'm going to draw a perpendicular line. And from here till here, I'm going to draw the line. Or what I can do is from this point, I'm going to draw a line of length 80 which is the true length of the line, and intersect it at the locus of B. So this is where it is going to intersect at the locus of B. So this is the true length of the line. So it has to be a continuous line. So from here, I'll be drawing a line perpendicular to the XY line, and then select arc by center point, measure this distance, and then cut a arc. So it is going to intersect here. So the true length is correct. Okay. So now we will just indicate the directions and the annotations. So for that, let me select the annotation text symbol, and this point is B2. And this point is B. AB and A dash B dash are the top view and the front view of the line respectively. And next, This particular point is the front view of this line, that is AB2, and this is the top view of the line AB1, correct? So we'll indicate the directions. So for that, let me select the leader option in the annotation dialog box and then select the properties, change the arrowhead color to black, click OK. So this is going to indicate the directions of the projector lines that has been drawn. So what was the procedure? So first we have taken the true length that is given to us, that is 80 mm, and then before that we also know the front view. So this is going to measure 65. So let me just show this. So this is 65. So this distance 65 is nothing but the top view of the line. So this has to be AB1. So AB1 is this. So from here, let me draw a projector and draw the line of length 80 mm, so that I'm going to get the point where the end point B is going to lie on the locus of B. And then this is the front view of the line as per the given data. So you can just see that the true lengths are the same in both the planes, and the angles are 74 and 69. So these are the values of alpha and beta respectively. So the value of theta is 36 degrees and the value of phi will be 51 degrees. So this is the true inclination. 36 and 51 are the true inclinations, and 69 and 74 are the apparent inclinations. So with this, we complete the problem. Thank you all for watching.